Hey. Welcome to Amber Skies. I'm Blades, and yes, what are we doing? We don't need that on screen. Righty. Oh, mouse, come here. I'm definitely well prepared for today, aren't I? Well, I am. There we go. That's what we're doing. Plan time, rendering API. 13 external warnings, that went down. Yeah, I was doing some tidying up. Let's go over that first. Changes. The build process was too complex for Visual Studio to contend with, so I simplified it all. I took away our GUI, I'm GUI build. I took away GLFW being built. In place of GLFW, which you've still got a link to, I've put in the binaries. I just downloaded the binaries instead of building it. And in place of building I'm GUI, I've just added it. Include PCH. Yeah, I just added it to the project. So I added those ones, and in the back ends I added these ones with the arrows next to OpenGL and GLFW. I did have to modify that, you know, so it could find I'm GUI, and I did have to put in the old PCH because Visual Studio loves its PCH. Precompiled header. Welcome to research. So, changed a couple of things, and now when I build it, solution, rebuild. Yeah, it builds I'm GUI straight into the static library instead. And look at that. Clean. It's clean and it does the same thing. And that's the whole point. And there's our triangle. I also fixed that little thing there. Oh, it works. Can't get it back, but it works. Just wanted to experiment with that. So let's go and have a look at that. And that was in... I haven't touched anything in... rendering. I've just been doing the research. So let's start with the I'm GUI thing. What did I do? Well, if you remember, yeah, I've been doing quite a bit in here. If you remember, we had that M show first window. Well, I took out that extra button. And M show first window, I kept that. But then I put it in an if statement. So if that is true, it does it. If it's false, it doesn't. It's as simple as that. It's just sticking it in an if statement. Yeah. There is that. Let's see, anything else? Thinking of using I'm GUI as a test system. That's why it's in research. And I might be switching research on and off with a toggle of some kind. So, could be interesting. Let's see now. Is key pressed? We're not going to be using that input test, are we? But we will have a lot of keys to do. So let's see why we've got all of these keys. So let's have a look. we are going, well, the shader we've got, have we really? Could leave that alone for now. I'll forget though, won't I? Alright, that's a note for the shader. We don't have anything like this yet. Amber colon vertex array, that might be a good idea. There's some ideas in here. We could do that first, probably. So that's it. We're going to have A, D, W. Yeah, you know what these are, don't you? Camera forwards. Yep. So that's up, down, up, down, W, oh no, A and D are left and right, aren't they? Silly me. So I can remember. It's not for you. The notes aren't for you, they're for me. Q will be rotate left. No, it's not rotate left. Q will be counterclockwise. Around the Z-axis. And that will be rotate the other direction. CW. There we go. I think that's enough, isn't it? We could put more in. Your Twitch export to YouTube was successful. Yay, go me! What have I just gone to YouTube with? It takes it so long to tell me. Where are we up to?
Right,
Yeah, Fraser Shark YouTube. And he's speaking to me. Don't speak to me. It's weird. Alright, that's the last one. So we've got... Did I put that one in? Yeah. Put it in the minigame engine series. There you go. It's all there if you want it. Twitch doesn't save them for very long, does it? I would like to know what I've done. Right, let's go to the top and have a look at this code. So at the top of the code I've got data. Oh, I've got a render command. We don't have any render commands, do we? You can tell what we haven't got by the fact that it's, well, a comment. Because we haven't got it yet. So data, I've changed a little bit. Started it at 0, 0 and put it halfway across to the right and a quarter of the way across the right and halfway up. so it doesn't look the same as the triangle that we have. We might modify the triangle we have so we can fit both on screen, but I want to see what happens, because that's what I do. This coffee's nice. And I've got the sniffles. Oh God. Please don't have the sniffles. That would be too much for me to handle right now. Indices will remain the same. And our vertex source, don't think I might have changed variable names. I have changed variable names, haven't I? Yeah, we have a view projection now. Well, we will do if we get a camera together. That's fine. So we've got a uniform. Oh, what about uniforms? Uniforms we can change once per draw call. Whereas these things go streamed in via the buffers. These come in from the buffers, so these are varying per draw call. That's why the V came into things. That's what that V used to stand for. I use it for vertex shader now, because we use more different shaders. There only used to be really two that people used. Compute shaders didn't exist. Well, not in the way they do today. So in comes the V colour, and the V colour goes to yeah, that's okay. Uniform only affects in here. That's going to be the camera, because we want to move it around. Right. What don't we have? A Vertex Array object buffer? Vertex Buffer code? Oh, it's a bit shorter, this. So, Vertex Buffer. Reset. How can you reset it? Vertex Buffer, what are you doing? Why have I got to reset there? Oh. Buffer layout. That vertex buffer is an object. So that means we need a class. Taking in that lot. Wonder why I wrote it like that. I know it's correct. All of this has been tested. So the layout. So amber buffer layout equals that. Vertex buffer set layout. Yeah. And after you set the layout, you can add the vertex buffer. Yeah. That's basically what we've been doing in English. There's a couple of words in there that I wouldn't normally use. So, create a vertex buffer. give it a layout for the varying data. Float 3, float 4. Yeah, that works out. Set the layout and then add the vertex buffer. Yeah. Sounds okay. I mean, obviously we do the same for an index buffer. Ish, sort of. But we don't have a layout. So the index buffer just becomes that. Shaders we've already got. I'm not overly keen on that index buffer. Seems to be a strange way of doing it, but I'm going to have a look at that. We might change it. These are old ideas, not new. Probably from years and years ago, knowing me. I've been dealing with OpenGL that long that let's just say I've probably forgotten more than I know. I have to make this flexible enough for a renderer to start off very basic and end up very complex, if I want it to. Still seems to be quite a bit of code. Is that good enough, do you think? I can fit both on screen, it's just one page. Makes for an interesting renderer call. There's our rendering. Set the position of the camera, set the rotation. Clear the screen, or do the clear colour thingy. Renderer begin scene, renderer submit, and end scene. And we submit the camera, the shader, and the vertex array. That looks sensible to me. Okay. What would we need to do any of this whatsoever? Alright, all these if statements are unhappy because, yeah, well, they're not doing anything. If statements that don't do anything are unhappy, I'll leave the render command for a minute. I think we're starting roughly around here. We've already done the context, I realised, after staring at it for a while. We haven't completely done the context, but hey ho, it's probably as good as it's going to get right now. So let's adjust ourselves from here. Let's have a look in amber skies at our source code, and we already have a renderer. We have the shader and the context. That's interesting. That's not supposed to be there. Okay, looks good to me. Oh yes, and if you want the code, it's available to you. I've checked. It's here at GitHub, Avengers/Amberskies. Don't forget to change the branch over to research, and there's all the code. Unfortunately, you're going to get in Amberskies under dependencies, I'm GUI and speed log and a glfw file. What do you get in here? Oh, you do get an include direction. Right. So glfw is okay as long as you're on Windows using Visual Studio 2020. Otherwise, you may need to change that. The I'm GUI, yeah, that's fine, and the speed log, yeah, that's fine. You may need to change those or look into changing stuff in there. Okay. As a happy error list, 13 warnings, all from, yes, you guessed it, the standard library. None for us. So just keep that switched off for now, unless it changes. That's why I have this little note up here saying I've got 13 external warnings. Alright, renderer, where shall we start? That's a good point. What notes? I've got a server full of notes. Put you there for a minute. So let's have a look at our server of servers. And see what notes we've got about this kind of stuff. Ooh, let's look at this. Let's try a vertex array. Let's see what happens. Right. Let's try this and see what happens. Wow, we've got this reset and everything. So let's grab ourselves a header file. So add new item. What are we going to call it? How's about Vertex Array API? Oh, I was going to do that other thing. Doesn't really matter though. Okay, so we've got one of those. That's good news. Won't need that really. We'll see if it works after. Whatever I put in here. What was the last thing we did? Doesn't really matter. grab my mini header. We're on what second, is it? Yeah. So it's O2. O2. And we're using namespace amber. Looks good. Alrighty, let's start with that. Let's add a CPP file. I think we might need it. Not sure. Vertex Array API. Pop you in. We will hash include our precompiled headers. If you're using that system, you can. You don't have to. And we'll hash include whatever our things is. Vertex header API. Don't particularly need that. Lovely. That's worked out nicely. Alright, files are set up. What we're going to put in here. What, Poppy? You alright? You coming over here? Come on then. Yeah, come on. Well, I'm not going down there. Are you coming up here? Daft cat. Amber Common, yes, we've got that in. We're going to need some kind of buffer system, aren't we? Yeah, we are. Come on then. Good girl. I knew I was going to get jumped on. Are things I'm beginnings to understand. Yeah, I am. Why did I make it into a pointer? Because we don't know how big it's going to be. That's why. We might want to start with a buffer. Yeah, we might want to start with a generalized buffer. Yes, that might be a very good idea. We need to know what a buffer is, don't we? Our game engine has no idea. And our vertex array needs to have an idea of what buffers are being made. Okay. Let's see how far I can get with this. Without that information. Class. Oh, wait a minute. Yeah, class. Vertex Array. Don't need any other than... no. We'll just make it a vertex array. I think that's fair enough. It can be public. And I'm not going to have a constructor. But I will have a virtual destructor. Remember, this is an API, so there shouldn't really be much in here that's real. Vertex. Yeah! And I am typing with one hand at the moment, sorry. But I don't have a choice. I'm not going to do much with that. Bind and unbind are always good stuff. So we can have virtual void bind. We know we're going to need that. It will be a constant. We won't be altering any information. And we'll make it a true virtual function by setting it to 0. Yeah. That means it must be overridden. If you're wondering, and that doesn't need to be overridden if you don't want to. So that's the difference between that kind of notation and when you see this kind of notation here. If I put 2 brackets at the end, it means it's optional, and it's not optional. We do need to be able to bind, and we do need to be able to unbind. So, virtual. Alright, let's see if we can get this other hand working. It's a bit dicky at the best of times, but hey ho, we'll try. Void unbind. Unbind is all one word. Can make it a const. And we can make it equal to 0. It's not optional. Next one. What can we have now? You'll see that most of these are void at the moment because I haven't got a clue. We can add a vertex buffer. That might be a good idea. It'll be a standard shared. This is why we need the pointers. Standard shared pointer of type Vertex Buffer. Not Vertex Array, but the Vertex Buffer. The array needs to record this stuff. Otherwise it's useless to us. And we'll take that in by reference and just call it Vertex Buffer for now. It needs to know. We don't have a vertex buffer. Well, yeah, there's that. Oh dear. We'll need one of them. And we're going to make that equal to 0. Yeah, it's not optional. We do need a vertex buffer. And if we need a vertex buffer, we can add more than one vertex buffer, by the way. You can have many different types of vertex buffer. So we'll leave that open-ended. But we can only have one index buffer. So we'll give that set index buffer. Can't have more than one index buffer, that would be weird. And that will be a standard shared, so we don't have to keep track of these things. And that's going to be an index buffer, I guess. So let's pop that in. We don't have one, but let's pop it in anyway. And we'll take it in by reference. Just call it index buffer. Of course. And we'll make that is not optional. That's looking like a class. Nothing in it. Better have getters. Yikes. How are we going to do a getter for that? Let's try virtual const. So you can't change it. Standard. Shared pointer. It's going to be a vector. It's got to be a vector. So we know about the vertex buffer, but we said we need more. We can allow more than one. So at some point we must have a vector. And if you're wondering why I'm able to do shared pointer and type all of this, it's in common.h. I forgot to mention that. I have them all in common. And I have a couple of things like the event system, OpenGL, and my logging system within common as well, so I can use those. That's why I have a common file. So I better have a standard vector. That's going to add another one of these braces here. It's going to add another one of these braces here. Angular brackets. Don't know what you want to call them. It looks like a bit shift now. That's bad news. And let's just get vertex buffers. And it's plural, because it will get them all. And we need to make it a const, so that you can't change anything. That might have to be removed. What a horrible line. That's the worst line I've written in ages. Never mind. I told you, we're going to try and do it. Hold on a minute, everything's virtual. Yes, it's a virtual class, it's an API. It's not a pure virtual class, but it's close to. Virtual const. Don't need the vector. There's only one index, so it's standard. Shared pointer. This is going to be the index buffer. Take it in by reference. And it's get index buffer. I like writing things like this, it's funny. Const equals 0. Not optional. Yep, not optional. That is way too big, that line. Way too big. Can I split that line down? Okay. It's just that this is in the middle of my screen. How are we doing? How are we doing out there in the wilds today? We have a viewer. Hello, viewer. If you have any suggestions, or you want the code, or whatever, you want a copy of the code, just let me know in chat. If you're having problems compiling the code, let me know in chat. It's all there on GitHub if you want it. You can use most of these files separately. It's being designed that way. So as you can see, we have a dotted line. That dotted line means that everything in here has an API through a dotted line to stuff that's outside of here. We do have a layers stack as well, which is internal. We do have a delta time, create window, I'm GUI. We're just doing the rendering API, which will be literally rendering API to whatever through a dotted line. It keeps the game engine separate. So you'll notice we've got platform here, which actually has all of the OpenGL and all of the Windows stuff. If I wanted to write the Linux stuff, I would have Linux and Linux window, Linux input. Do you get the idea? In fact, they're probably the same code, but I don't know that because I haven't run it on Linux. OpenGL's obvious. It's just going to keep OpenGL in it. And we're using GLAD for OpenGL. And that's how it works. So you'll see the word API come up, which means it's passing through into the platform layer, because it's platform dependent. These are OpenGL dependent, as we can see in Sandbox rendering. That's what the code looks like at the moment. OpenGL everywhere. All this purple stuff. OpenGL. Yeah, that's an int64, that offset, I found out. That's 2 underscores, int64. Wow, took me a while to work that one out. That's what I was doing yesterday. I was trying to track down those. So this is unbind everything. Yes, there's that as well. There's the shaders that we use, slightly different, just in name. I put a underscore in front of those two. And the rendering was OpenGL. So clear, that's your clear command that we're going to have. And that's basically it. We don't have any kind of camera system at all. Onwards and downwards. Do I need a CPP file? Are we going to keep anything? Oh, wait a minute. We've got bind and we've got unbind. Something that we do want. Yeah. Static. Vertex Array. Yikes, caps lock went on. I thought I'd hit that button by accident. Array. Star. Because I want a pointer. And it's just going to be create. This is how we create things. There we go. Returns a null pointer. Isn't that lovely? That's what you want to see every time you make one of these, isn't it? Null pointers being passed around. Alright. I think I might be able to do this. Without the buffers, I'm going to have to make something up. That's a bit dodgy, isn't it? We're going to have some way to know what we're in, like OpenGL, or whether we're using OpenGL, whether we're using Vulkan or something like that. So we'll need a switch. Well, we don't need a switch, but we're going to have a switch. And we're going to switch on our render API, I guess. No idea. Making it up. I'm going to use get API. Because we don't have a render API. But it would be helpful if we did have that kind of thing knocking around in the background somewhere. Case. Render renderer. No, I'll keep it render API. Not certain. We're going to have both, aren't we? Probably. And that's going to be API. None of this works. I'm making this up. None. We can use amber assert. I'll do that instead. Is that right? I can never remember how to do switch statements. Why can't I remember how to do a switch statement? Not when I'm trying to make things up anyway. Nothing in there. Ah, that's because it's there. Oops. It's not that I'm looking for. It's Qt projects. None. Okay. Fair enough. Absolutely nothing there that's going to help me. I don't use switch statements. Oh dear. Expected a semicolon. Stuff it. I'll make it look bad. We'll just carry on the same line. Amber assert. We have that, or we should have that anyway. False. So assert false. In other words, this ain't working because we haven't got an API. So this will be Vertex Array API. Always tell myself where I am so I can find the code. Throwing out the assert, and it's going to be, where's amber assert then? Is it not in common? No. Renderer API specified. It's going to be OpenGL for the moment, so this should never hit, but you have to be aware of that kind of thing. Let's just have a look at that common. Amber assert. There's a semicolon at the end. And there's a semicolon. Is that Windows only debug break? I think I might have asked that before and looked it up and found out that it isn't. Oh well. Find out when we put this on Linux, won't we? Let's have a look. Is it case colon? Where's the colon? It's after none. Okay. So obviously we want a case we can find. That might help. I'm sure that'll go down into brackets. It might do now. That's better. That looks better to me. I can see it all now. Right. Hate lines that you can't see. Alright. Let's do another one. Case. Now we can know how to do one. I've got something to copy. API. I'm not just making it up. And this will be OpenGL, won't it? This is what we'll be using. Currently, there's only two that you can have. And this will be return a new OpenGL Vertex Array. That's where you get it from. That's how you create your OpenGL Vertex Array. Another file we don't have. That looks awful for some reason. Alt, Shift, click. That looks better. Still got that return null pointer. I don't really want that to happen. What can we assert? False, obviously. And it is a Vertex Array API unknown renderer. And that's the message, I guess. Okay, my notes have a bit of discontinuity going on here. They've put a semicolon. It's telling me to use a semicolon. I'll use semicolons. Just in case. Oh look, it did that. How weird. Get back. Back, boy, back. That's Visual Studio being kind and saying, hey, present it to the world like this. No thanks. Alright, any coffee left? Oh yes. Lovely. So that's what I want my Vertex Array API to look like. We are missing a few things, like Amber Assert. It's quite right, it doesn't exist. So we're looking for a renderer API, an OpenGL Vertex Array, this is a bit complicated, and a buffer. Those are the things that I would want. Well, I'm not overly interested in the buffer, or am I? I think that's where we should start, maybe. Does create work? It does. So if we could sort out these buffers, I think we'd be on the right track. Vertex buffer and an index buffer. Well, they will probably be buffers. Shall we just make a header file and see how far I get with that for a buffer? Yeah. I think it's probably a good idea if we can provide those, the index buffer and the vertex buffer. There's a bit more to this than meets the eye, unfortunately. We have to do quite a lot of extra work here. And a bit of code that is going to be repeated, because we're going to have to create those buffers. So this create idea will be repeated, assuming I've got it right. Alright, I like the idea of that. So we can probably reuse that piece of code. And then all we have to do is change what's returned when we create a buffer. Creating a buffer, though, is going to be slightly more complex. We're going to have to know quite a lot of things about the buffer so that we can create it. Okay, so the buffer, we need all of this information. We need strides, we need offsets. We need to know the layout. We need quite a lot of things here. That's an awful lot of things. We need to know whether we're using floats. Or unsigned integers. Sizes of things. Okay. I think we can do that. It's not that hard. It's just might take a bit of typing. I hope. Call that rendering layer good. Alright. Don't really need this. If we think through it properly, that will automatically start filling itself in. If we don't think through it properly, that stuff will go. Ah! Don't do that to us. New item. It's on CPP file, isn't it? Let's do the header file first. I like doing the header file first. So this is going to be buffer. And it's an API. And it can't create the buffer for some reason. Visual Studio says, no, you can't have that. So what do? We say, Visual Studio, what the hell are you doing? Okay, that's alright. That's alright. We just closed those two. So what was that? Vertex Array API. API. Design with no support. Do not run this. How do you get rid of it doing that thing? I don't know. Okay. We'll get rid of that lot. So you've got the code now if you want to go and get it. But it's made up code. It won't work. Oh, it got that, did it? But it didn't add it. Alright, we'll include that in the project then. We'll see if it can add a new item. We'll have a CPP file. I don't know. I should include It's PCH, isn't it? Hash include. And that will be buffer API. Alright, that's okay there. Alright. So we've got two files. Do the files look okay? Correct date. Correct date. Good. I'm thinking of adding another line to this. Last edited date. Who cares? Somebody might. So we know we're going to have a create. We're going to have two creates. Maybe three. Oh, let's switch that off and not even worry about it. Let's work out the data we're going to have to put together. So let's just concentrate on the header file. Data. What data do we need to know? Good question. Move that thing out of the way. We're okay there. Right, so layouts require shaders, don't they? So let's try and think through that. So this layout thingy here, that's 0, and this here, that and that are calculated depending on that 0 there right. So yeah, it involves the shader. So we're going to have to involve the shader. Let's do that. And we'll just use an enum. It's the easiest way of doing this. So what type of data are we going to be passing through to the shader? I think that's simple enough, isn't it? So we'll start off with none, because that's an easy start. I can do that. So what kinds of data can we pass through? Anything really. I think the only thing that OpenGL doesn't have is a bool. So I don't want to use any OpenGL here. Why did I just do that? May as well keep these together. Float. Or two floats. This looks a little bit like how in Dungeons and Dragons trolls count. That's a float, that's a 1, that's 2. I'm guessing this is going to be a 3. And lots. Oh, lots plus 1. Oh, lots 1. That's enough floats. I'm not doing any more than 4. We can have matrices. That brings me on to the maths. I'm not doing any. I'll have ints. Oops, don't make it into a proper one by accident. That's why they're capitalised. Int 3. I suppose we could have an int 4. And for those that are stupid, we'll end on the one that we can't have, which is a bool. There you go. Those are the data types that you probably are going to use. There may be more. There may be more. No idea. Just add them if you find there are more. Alright, what next shall we have? We can have, it's an API, it's a static. Unsigned int. And we'll need to know the size. Shader, data, size. And if we want to know that, we're going to have to take in the shader data type. As type. a switch because we're being lazy. We'll switch on the type. And we'll have case. Shader, data type. And then they'll all come up. We'll take a float. Return. How big is the float? 4 bytes. There you go, I bet you didn't know that. It is now. So float 1, float 2, float 3, float 4. Yep. And it's going to be 4, 8. That's there. 12, I guess. 16, maybe. How's about 20? Is that right? No, it's not right. Float 1 is a float. Duh. Being an idiot. Not unusual for me to be an idiot. I'm good at it. Do you get the idea? So this is the size in bytes. Shader data size. Should say bytes, shouldn't it? Really? I'm not overly worried. Case. Shader data type. Colon, mat. Mat 3 we did. Return 36. Believe it or not. And that is 64. 64 bits. And that's a 4. Next up is integers. Yep, that's better. Just take out the idiot bits. Shader type. And it's an int. How big is an int? This is going to blow your socks off. It's 4 bytes. How amazing is that? 4, 8, 12. Bit of repetition going on here, but hey ho, they might change in the future. You never know, do you? It's one of those things. 2, 3, 4. And the last thing we're going to have, I guess, is a bool. And that's that, and it's a bool. Guess how big a bool is? It's 1. It's 1 byte. It's either true or it's false. It's 1 or a 0. How can you represent 1 byte? Well, it's char star, or char. Is the data type you're looking for there, which is why OpenGL doesn't have it, because it relies on numbers. Is it really worth putting in? Probably. Amber. Assert. It is false. Can we get back to the center of the screen again, please? Told you this would be a bit of typing, didn't I? Oh dear. Oh, thank you for a follow. That's very nice of you, Polyvoid. It's appreciated. We will take a buffer API. I need to know where it's coming from when we get assert failures. If you want to know the macro or anything like that, I'll stick it up on screen for you. Anything that you need, just let me know. If you need something for your own projects, a lot of these files you can just drag and drop. Literally, they are designed that way. We're going to say unknown shader data type. There we go. Why did I capitalize that? Don't know. It's a message. Don't need to do that, do we? Think that'll do. We're not doing defaults, are we? Nah. Alright, let's construct ourselves some kind of buffer. Well, no. We need data for the buffer. Why is my Amber assert not working? What's wrong with you? Expected a declaration. Why did it expect a declaration here? I've missed something. Punctuation. Look at the punctuation. No. We have got common in, haven't we? Yeah. We've got a semicolon missing. Return 0. Better return something. I find that interesting. Is it on the switch? I wonder if it's looking for a default on the switch. Hold on a minute. I'm outside of the class. Yeah, I'm in no man's land. Helps if it's inside the, yeah, I'm outside of the function. It's not a class. Right, let's make a class. Well, not a class, no. Let's make a struct. What we're going to call it? This is going to be the data for the buffer, or buffer data. I don't like the word data. Don't use it. It's a bad, non-descriptive thing. So it's going to be an element, I think. Just to make it hard for me to spell. Okay, we're getting somewhere. Starting to put a buffer system together. Let's go with something stupid to start off with. The reason it's a struct is because it's all public. It's the same as a class, but it's just public, whereas a class defaults to private. It's the only difference in C++. In C, it's slightly different. It's slightly different. I could make it a C struct. Doesn't matter. Takes up the same size of memory. We'll have a name. Why not? We can call things names, can't we? We could use names. We need the shader data type after all of that typing. Notice I'm not putting M's in front of them. An unsigned, I think it was integer that we used for the size of the data in bytes. I could call it byte size. Oh, what a fantastic idea. I'm having that one. That one's on me. Byte size. Yeah. Considering when you're programming, you're making stuff up. You can change it any way you want. So we've got type byte size. We needed to know the offset, didn't we? We were calculating and messing around calculating offsets, and this is why. Now, offsets were strange. Let me just go and find out. Yeah, this is that idiot one. It's underscore underscore int 64 for the offset. Glad I remembered that. So underscore underscore int 64 will give me. I'm only doing 64-bit. Sorry, not doing 32. And that will be the offset. If you don't do that, you get a warning in Visual Studio. Sorry, whatever this is, MSVC, Microsoft Visual C++, or whatever they want to call it. Visual Compiler, God knows what they want to call it. This system would give an error saying that you are expanding it expected a semicolon. Oh my god, I hate that message. It would give you this error. Using a parameter plus on a 4-byte value and then casting the result to an 8-byte value, we've got to use the right number of bytes because we're going to be casting this to a void star. And a void star in this system, because I'm on a 60, is 64 bits. So I've got to use a 64-bit. As you can see by our little thingy here, which isn't working. Remarks example. So that will give you an int 64x equals I less than 31. Yeah, that will get, sorry, that's a bit shift. That will give you a reporting error, but that will be correct because I is then a bit 64-bit. So you'd have to do a static cast on it. You've got to make sure it's the same size when you're doing operations on it, especially when casting. So that was an interesting thing. Who's expecting a semicolon? Oh, you are here. Yeah, of course you are. Silly me. That's why I don't look at the warnings. So we needed an offset. We needed to know about normalization, and that was a bool. Normalized. So we'll need that data. Anything else? Can stride just be calculated? So that normalization thing is that GL false there. It is a bool as well. Good. Well, it's not a bool. It's an int. But hey ho. Normalized. Right, let's set this struct up. So it's going to be a buffer element. And we'll just take the default because I don't care. Don't care about that. So I don't need a destructor. Good. Oh, good grief. Right, let's overload that. This is a good thing about C++. We can overload. What should we take in? We'll take in the shader data type. We should really take the name in first, shouldn't we? Const standard string. It's const because we're not going to alter it. Take it in by reference. We don't know how big it's going to be. Name, comma. Then we can ask if it's normalized. We can make that optional by giving it a default. I think that's all we need. So, name is going to be name. That's right, isn't it? Yeah. Type is going to be type. Anybody who's a Java programmer or a C# programmer or whatever will remember this. What's next up here? Byte size. Byte size. Byte size. Thank you. Will be shader data type size. Why won't it go up and down on me? Use your mouse. There you go. Byte size. Shader data byte size. No, it's a type. And that will just be of type. There we go. That's happy. What's next here? Offset. That's easy to do. Offset, we can start at 0. And normalized. There we go. Lovely. I think that'll do. Right, what's next? It's just storage. That's all it is. Come on, hands. Hands are hurting. Should I go and make a cup of coffee? Mind you, I'm not surprised they're hurting. That's what happens with age, unfortunately. You soon start running out of fingers, and then start running out of hands. It's a shame you can't take your old ones back and get a refund. A bionic programmer. But I'm not a programmer, I'm a systems analysis, an analyzer. Analyst. The only word within it being an analyst is you got syst at the end of that, and that's not good. It's never good to have those. But it is a good description of what an analysis does. Bends the truth. Warps reality. Interesting. Interesting word. I'll try and finish this before I go and make a cup of coffee. How about that? We need to know the component count. Okay. Unsigned int, because it's got to be positive. Get component count. Why have I called it component? And it's const, we're not making it change anything. Oh, we don't need anything to make changes. It's to be used in calculations or passed to OpenGL. That's an interesting idea. Component count. That's this number here. They just say size. They just say size. That gives us a free hand, really, doesn't it? We'll call it a component count then, who cares? Do we? Probably. So, guess what we're going to do? Switch, and we can do that on type, can't we? Because we have one. We're going to have to do cases again, aren't we? Would it be for this lot? I wonder. Well, it would, but I don't think it's for the bool. And now we have to start wondering about the maths. Am I going to write a maths library for this? Am I hellers like? We're going to use GLM. Now in GLM, Graphics Library Mathematics, which is out there on the internet, we're just going to drop it into our dependencies. We could do that today. Don't forget that we're going to use it. Otherwise this makes a mess. Do everything. Do the lot. Whoa. I didn't know you could do that. So, that's 1. That's 2. That's 3. That's 4. GLM. 3 and 4. That's a 1. That's a 2. That's a 3. And that's a 4. And we'll leave that as 1. There's a little old bool hanging on the end there. Alright, that was easy. Less typing to do. Ding. Oh, that wasn't correct, but never mind. Aldo, I'm not interested in your errors right now. What the hell are you doing? Stupid machine. I know it's got errors in, it's not runnable. Put the right message in, that helps. Okay, now we come to our first class. That's basically all the data that we need, I hope. I think I'm going to go with that as data. I think it looks good. If anybody can see any mistakes in that lot, just chuck it in chat. I think at this point I will go and make a cup of coffee, because we're going to start doing the classes now. And I'll be right back. So all of that data, what does it make? What does it make? It makes me proud to be a programmer. Not. Because I'm not. How are we doing? 1:58, 2 hours? Yeah, that's not bad. Not doing too badly then. We might actually get this done today, this buffer. If we're lucky. I don't know. What shall we have next? We can have the buffer layout, can't we? That will be a class. So, buffer layout. Everything to do with buffers today. We can take a standard vector of buffer elements. Does that look right? Yeah, it does. We'll have that. What else should we have? An unsigned int for the stride. Because we don't know what it is. We'll do that. Yeah. Alrighty. I don't really care about a destructor. So buffer layout. Can equal default. We don't really care about it. It's not why we're here. And we can override that. With something else. Okay, check my spelling. So, standard. Oh God, what are they called? Oh, initialize list, that'll do. We'll use one of them. And that can be with buffer element. Yeah, that'll do it. Yep, that'll work. I hope. Always say that, don't I? Is that all we need? We've got the stride equal to 0, just initialize that. And I think we've got it. So m elements equals elements. Normal? What's wrong there? Oh, it's gone away. Good. It's because I did something weird, initialize a list. It probably didn't understand what the hell that meant. let's make something up. The constructor can do something for once. It can calculate offset and stride, I guess. Yeah. Not that we've got that, but hey ho. That will be a private member or private function, method, whatever you want to call it. Too many damn names for all this stuff. And if you want the code, just say so, and the code is available on GitHub. This part isn't because I haven't written it yet. So we're into the buffer layout. What kind of things would we like to do? Getters, setters, begins and ends, buffers. Sounds good. Yeah. Oh god, we're going to need iterators for that bloody list. Ah. Whoops. Never mind. Inline. It's going to be an unsigned int. Probably forget stride. And that's just going to return underscore stride. Funnily enough. Alright, what next? Get elements. Alright. Inline. Don't you dare. I'm going to const this one. Nobody's allowed to change our buffer elements except for us. But it's a standard vector of buffer element. That one. You can have it by reference because you don't want all of it copying. Get elements. Yeah, that'll do. And that's just going to... Oh, wait a minute, let's const that. Don't want anybody doing anything with this. No messing me about. No changes, please. Protecting the data, basically. And that's return m underscore element. Plural. Okay. Anything else it needs to do? Nah, not really. Ah, I hate you. Forgot about that. Okay, so that's get elements. That's not bad. We've written this with only one error so far. We're going to need the iterators begin and end for the elements. Otherwise, we won't be able to use them outside of this class. How do you do that? Let's try a standard vector of buffer elements. Hold on a minute. Yeah, that'll be fine. And we'll need the iterator, won't we? Have we got an iterator? Yeah, we have. Good. Begin. I'll stay on this line, or it'll mess me up again, won't it? That's just going to be m_elements. You have to actually do this because it's overridable. Elements dot begin. There it is. Yep, that's right. Line's too long. We'll just pop that in. We'll need end. Same thing really, isn't it? End. End. So that gives us the beginning and the end of all of the data. We need an override. What about the constness? That can be used in a for next loop, or you might just want the iterator itself, the position of the iterator at the current time, or whatever. Now that function is a const. It's a standard vector still of buffer elements. Sorry. But this time it's going to be a const iterator. Begin. And yes, you can have the same one. We can overload this. But now it's a const. This is one you can't change. And I got it wrong. That's not going to work. We're overloading things here. They have to match. If they don't match, we will mess up. For God's sake. Oh, thank you. You press Ctrl Z and it goes backwards one. Thank you. Is that right? Yes, yes it is. That's end. That's end. So I've got const overridden and an overridden standard iterator. Okay. I think that's it. you think we need anything else? We've done everything we need to do for the vector. The offset and stride are being calculated in private, so let's do that. Not open to the public. Void that, whatever I put there. And yes, we are still in the header file. Will we ever get through to the CPP file, do you think? Oh yeah, for creation, of course. Right, here we go. What did I say that offset thing was? It's that. It's that weird one. Trust me, try anything else there, if you dare. Could be a U-int, I suppose. Nah, we'll do that. There we go. I'm going to make that equal to 0, I think, to start off with. And mstride. Do the same. We already have. Don't trust the system. Okay. Do it properly then. Okay, 4. Now we've got to be careful how we use these 4 statements, haven't we? For each, well, I don't know what they are, so by reference. For each element in elements, we shall do the following. So element dot offset is here. And that's going to equal offset. Funnily enough. That's wrong. There is an offset of function. I should really possibly use that. And then we can, that allows us then to increase our offset. Ah, it's a plus equals, isn't it? Element size. This is why we had all that stuff up at the beginning. Type, byte size, there it is. Okay. And stride. That's a plus equals. The same. Yeah, that's right. I'm hesitating because I'm trying to work out whether it's supposed to be in bytes or not. And it is. I did check yesterday. So my apologies for hesitating, but hey ho. There you go, that's that done. I think we're done with that. That's all we really need for a buffer layout. It's a lot of information just for a buffer layout, but it'll work, he says. Okay, let's do a vertex buffer. And everything that it should now contain. We've got enough information. I don't need to inherit, so that's good. I think we've got a cat downstairs. I'm going to be kind. I've actually got this wrong somewhere. We've done it today. There. But it's virtual. Doesn't matter. Okay. Doesn't exist. What about here? We can go virtual again. This is an API. If you might notice, there's no OpenGL commands at all happening here. This is independent of any OpenGL. We'll have to write that separately, because that's not part of the game engine. We might decide later on to do Vulkan or DirectX, or what is it called? Direct Draw or whatever it is, 3D for Windows. It might just be Direct 3D. But I'm going to go virtual on this anyway, so we'll put the Destructor in. And again, optional. So that's fine. Want our bind and unbind as usual. May as well. There we go. Make those non-optional, because you have to bind and unbind a vertex buffer or it won't work. Some way of getting the layout. So that will be a const, because we don't want them to alter the layout. Yeah, that's right, layout. They can only have it by reference. We do have a buffer layout somewhere, don't we? Yes, we do. Good. Get layout. That'll do. And we will wrap that up as being const. Don't you dare touch my data. That means. And we'll make it non-optional. It has to be implemented somewhere. Alright. Remember, it's an API. It doesn't do anything. All the implementation for this currently will be in OpenGL here. So we'll have to write all the OpenGL, like Opengl Buffer, will have to be a file in here, probably, where we'll do all the implementation for all of this. It's definitely in platform, because this is for OpenGL only. And that's why it's not inside of the game engine. Anything that is a dependency or something that we might want to change in future can't go into the game engine. If you put it in the game engine, then changing it later means a complete rewrite. You have to rewrite the whole game engine. Why? The answer to that is you shouldn't need to. You should just be able to add another one of these and then fill in the blanks for the implementation. You don't need to touch the API. The API only changes if you decide you want more facilities from the API. The API doesn't change if you change the back end, which is the platform. Very clever way of programming, and that's what C++ gives you. It gives you, well, the only part of C++ that's worth having, really. And I have noises downstairs, I'll have to go and investigate. But it's the only part of C++ that's useful, and that is the overloading of functions and inheritance, which gives you, what do they call it? Changeability or something. Okay, we've got a cat invasion. That's a window cleaner. It wasn't a cat. I didn't check on the cats. Back in a moment. My goodness. Ow. Alright, vertex buffers. Get layout, that's a good idea. How about set layout? That might be an even better idea. Virtual void. It's just set layout, isn't it? What we're going to have in here. We're not going to be changing the layout, so it's const. Buffer layout. Why Why didn't it come up? Have I got something wrong here? It's not doing anything. Oh well. IntelliSense has probably died. We'll take it in by reference. And we'll call it layout. Curry's perks. I don't really need anything that I know of. Anyway. Thank you though. And we'll make that equal to 0. So I've got to implement that. And now we come to the nasty bit. Static. This is what we do need to implement. Vertex Buffer. Oh good, it knows about that. Pointer. Create please. Now I know why we're using pointers at the other end. Alright. We'll take in float. It'll be a pointer for the vertices because it's going to be held in some kind of array. So we can take those in. And we'll take the size of the array. Yeah. Unsigned int. Let's have a look. What did I put? No, that's the rendering version. That's the OpenGL version. Research, I put in what I think we needed. Create vertices, size of vertices. Vertices is bytes. Isn't it? So it's byte size. Yeah. Modular 1 hypernym. Probably. So calling this size isn't really helpful, is it? So it's vertices byte size. That's what we should call it. Yeah, we'll have that. Control S. Ah, good, it came up. Alright, we have a thing to make. Alright, leave that thing alone. Why do emotes not work in your chat? No idea. Ask Twitch. Do they not? They work in chat here. I can see your emotes. Dancing around, little blue blobby thing with green hair and sunglasses on. Yeah, and that one. in the one on your video? Oh, it does. It's here. Little face. It might not do the animated one, and I'm not sure about that. Because Twitch is Twitch, and I'm not using Twitch to broadcast. Yeah, it doesn't do animated ones. That's because I am here. I'm using AMD. So there's no way for me to program that. Sorry. I'm just using my graphics driver to broadcast. Oh well. It's not something I've ever thought of, actually. Maybe I can program it into that. You prefer OBS? Well, yeah. If you've got the amount of time that it requires to set it up, yeah. I just found that the sound controls on OBS fluctuate. So I stopped using it, and I went on to Twitch's own version of OBS, which is the beta test thingy, and that worked okay. And then I dropped that because I realised I didn't care, and just used my graphics card instead. Because then nothing can interfere with what I'm doing. There's less programs interfering. It just all gets done on the graphics card. Very simple, very fast, very efficient. Right. We could do that, I suppose. No, let's get this index buffer going. We'll have another class called an index buffer, I guess. Yeah, I'm not a big Twitch. Well, I don't get followed a lot. Well, I do, but I don't get a lot of viewers. So at this point in my life, I don't even earn anything. So I'm not a professional broadcaster. So unless I get people really interested in wanting to promote this channel for God knows whatever reason, I'm really not going to try and put music in the background, that kind of thing. I'm not going to be doing any of that. I'm just going to have a nice simple setup that can't go wrong, even when it does, and hope for the best. If it does become popular, then fair enough. I'll do something about it. I'll probably use OBS. You're quite right. Because OBS works on Linux as well. Ah, you were lurking. Good stuff, good stuff. Lurking's good. Are you interested in C++, C, or... Ah, bless. Yep, that's right. I was getting too many bots. I was getting more bots than there were people talking. Very distracting. So, index buffer. We're going to do the same, aren't we? Yeah. There we go. Oh, that's okay. Yeah, that's what I say to people. If they want music, put your own music on. It's probably a better idea. Because you might not like what music they give us nowadays. I don't even know who they're with now, because they've just made an agreement with somebody or other, I believe. Let's get the count. Unsigned int we used for count. Yes, unsigned. Got to be careful with these. I've got to try and keep these in line. Unsigned int, get count. So that looks easy. Don't want to be people changing it on me, so without my knowledge. And then of course we've got the create, haven't we? And we want indices. And we don't want that. We just want the count. That's easier, I think. So we can pop you in. Oh, okay. No window came up. Never mind. We're not going to get a window out of Visual Studio today. Lovely. I wonder how it decides that. Oh, I know. It's because I haven't saved it. Okay, let's get rid of you, your, and your. And now we can open up the other one that we did. That one. We'll come back to you. A lot of this should now be filled in. Ah, we haven't got an include. That might help, do you think? I don't know. Buffer API. What am I building? At the moment, I'm just messing about with a mini game engine. I'm building a rendering system for it. Oh look, all the errors disappeared. Wow. I like that idea. Right, that header file works. This doesn't. It needs a renderer. And a renderer API. Oh dear. Doesn't matter. We'll make one after we've done the buffers. So let's clean up this buffer file. Here we go. God, what a mess. There we go, that's a bit cleaner. I can nearly see what's going on. So this is going to be the same switch statement that we've already used. This one. Well, sort of. This one. Yeah, it's just going to be a mini one for 3D. I've got a game which I've designed, and I want to make it work properly with like an entity system and everything. And I thought, instead of making the game and then the engine, well, I've already made the game. Well, most of it. I just haven't put the items in. And it's in 3D. And I thought, well, hold on a minute. I'm going to make the game, so why don't we actually make a proper game engine that other people can take bits from? You don't have to take the whole engine if you don't want it. You can just take parts of it out, like the GLFW. If you don't like GLFW, take the GLFW out and put something else in. You might want to use SFML or something. I don't know. Or even SDL. Woof. Good luck. That won't work. So, what do we got here? We have a switch statement. That looks okay. That doesn't. That's Vertex Buffer. We'll just call it Buffer API. And this is Vertex Buffer, isn't it? Okay. That tells me where I am there. We can also put that into the other one, can't we? Like that. What other APIs do you plan on supporting? Vulkan? Yeah. There's DirectX stuff, Direct 3D, whatever it's called. Vulkan, Metal. That sounds fun. I've done a bit of Metal, I've done some Vulkan. I should be able to do them. Can't see why not. So you can put OpenGL there, and you'll just choose whichever one you want to use, and the API at your end will stay the same. It won't change, no matter which one you're using. So the API here will not change. It will not be dependent on the back end. It'll just stay the same. So it won't matter. Does that look all right? No, it doesn't. Return something. A new OpenGL Vertex. It's gonna be a buffer, not an array this time. So I'll have a buffer. Yeah, so what I've done basically is just keep everything uncoupled from the platform, so that nothing in here depends upon it inside of the actual engine. So I'm just designing the API now for the user to be able to use whatever they like. And of course, a lot of the stuff hasn't been written yet, so we're just going to get problems. What would we need to do an OpenGL Vertex Buffer? Oh, it's the vertices and the size thingy, isn't it? It's this one. Yeah. And what did this call the other thing? Something stupid, probably. Yeah, I called it something stupid. Yeah. You can have your renderer picked at runtime, yeah. Absolutely. That's why this is doing this switch statement now, to find out which API you're using. Not really fancy now. It's straightforward as long as you stick to the laws and the structure of the program, and keep things separate. At the moment, if you notice, I've got this check shader OpenGL. If you check my shader, I've got OpenGL in it. That's got to be moved out. You can't have that inside here. This goes in the OpenGL platform. It doesn't belong here, it's got GL in it. So that's a problem still. That's got to move. I was going to do that today, but then decided to start on the rendering system and do that last instead. Because I don't know how much I'm going to have to do to get an API running. Shouldn't have to do too much. It's only OpenGL, it is the simplest one. So, Vertex Buffer create, vertices byte size. Oh, they were at the top, weren't they? Duh. Why doesn't that one come up? because it's comma. Punctuation helps. Computer graphics are easy. OpenGL is a state machine. It's a box full of switches. What you do is you put your data next to a switch and switch it on. And then if you don't want to use that data, you switch it off, or you replace the data to use other data. And it's got quite a few switches. It's got about 100 plus switches that you can mess around with. And I've started off with the simple ones. Create a couple of buffers and draw a triangle as you do. I do have something on Vulkan, but it's not on my website. It's on the place that I'm retired from. Well, retiring from at the moment. It's on Amber Sky's website. Let me see if it's still there. My website is YouTube Fraser Sharp, obviously. Is Amber Sky still here? Yeah, we're still here. It's the one with the planet. Yep, you see, I even used music in those days. Playlists. oh god, yes, Java. Lots of research and development on 3D. Lots of thoughts and rambles. Where's metal? Bits and pieces. Testings. Programming 3D. That's another one on how to look at 3D. I broke that down into stages. So there's stage 1, 2, 3, 4. Goes all the way through. Trying to make a 3D game engine, which I didn't like. I can't see it off the top of my head there, but I have touched upon Vulkan in one of these, probably. Should have done. There you go. Research and development Vulkan with Qt. You might want to look at that one. So there's that. I don't know if I did anything else in that one. Maths libraries. There's tons of stuff in here that I've done in the past. But this is all research, that's what I used to do. Research to find out whether there's better ways of doing a simple idea. And there's a lot of failures in there, obviously. Which is fine. I use Linux, Windows and Mac. I'll program on anything. And most of my code will work on anything, so there's that. So if you're interested in Vulkan, you might want to look at that one. But Amber Skies will no longer exist on July the 1st of this year. But the YouTube channel will be left for posterity, I suppose. But I probably won't be continuing to support it. Okay, that looks like a Vertex Buffer creator. Get API, yeah. Non-OpenGL, yeah. That's okay. Do the right thing. And basically say, sorry, nothing else supported if it isn't there. Good. Right, on to the index buffer. That was easy. I'm guessing it's the same thing, but with an index buffer. So we don't want an OpenGL Vertex buffer, we want an OpenGL index buffer. And that will take in indices and a count. Pretty easy, really. You see how it's not complicated? I don't do anything complicated, ever. Now, anybody who's just seen that who's a professional programmer would be tearing their hair out, shouting at the screen saying, "You've just copied and pasted code. Why don't you make it into a function?" And the answer is you can. This can be refactored into returning a true or false. And then on that true or false, return whichever is the correct thing. Not going to do that, can't be bothered refactoring yet. It's not that stage of the game. Right, so everything should work up to this point. Looks good. Oh, and all this code, by the way, is there at avengersambusguise.git. And we are on the research, not the master. So I think that's the buffer API. Only allows OpenGL currently. Because I haven't got anything else to. Because I haven't written anything else yet. There you go. That's what I've just written. Okay. We've nearly got a vertex array. And we've nearly got a buffer API. What part of the buffer API doesn't work? Well, this part's okay. That's all the data for it. This part doesn't work because we don't have the renderer. And it's the same for this. So without doing the implementation for everything else, I think I might start on the renderer. That could be complicated. There's two parts to that. There's a renderer, get API, and then there's the renderer API. It is the most complicated part, I guess. And it's all we really need to finish off the API. Oh no, we'll need a command system as well. Oh dear. The API is by no way finished. In fact, it's going to be a work in process for a long time, I think. But we need a start point. Otherwise all of this just won't work. Alright, let's ignore this. How many errors? 13. That's good. We haven't made any extra warnings, but we do have 23 errors because we don't have the renderer. Alright. Let's add... What should we do first? Whoops. Thank you. What shall we do first? Doesn't really matter, does it? Let's do renderer API. What did I actually call it? Hold on. Hold the phone. That one. Let's do that one first. Renderer API.h. Will we need a CPP file? Probably. I'll do. Let's do the usual includes. We have the pre-compiled headers, and we have I'll just put R in, it's easier. Ah, thank you. That one. That's the right date. Doesn't need anything in here. Hash include common. That'll do. Lovely. So, 2 files set up. Can I have an end line as well, please? Thanks. Correct. 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 Looks normal. Let's go. Ah! I think we might get stuck in here. Thinking it through. Who cares? Class. Let's give it some space. Class. Renderer API. What a stupid name for a class. Who cares? Keep going, keep going. Let's get it done. Public. So let's have the class API. We've been putting it in everywhere, haven't we? So we better put it in here actually. So it's going to be an enum, obviously, class, and it's just called API, I think I called it. We'll soon find out. And all we put in was non and OpenGL because that's all we've got at the moment. OpenGL. That's a comma. Thank you. That's it. Alright, we got some data. That was... Right, so what do we want the renderer to do? Let's have a look. What did I write? Set clear color. Alright, we'll have that one. We haven't included that in anything. We've done all of those. We've done all of those. Clear, we haven't done. Begin scene, end scene, submit. Alright, we can do those then in here. Do I need a constructor? What for? We've only got an API. It's the only thing we're probably going to store, if anything. Can I put it in here? I don't think I can I? S for static, by the way. No, that's not going to work, is it? Unless I forward declare it. I'm not forward declaring it. Alright, we'll leave that to last then. Okay. Virtual. It's an API, so it's virtual. Doesn't do anything. Void. Set. Clear. Whoa, don't do it that way. Set. Clear. Color. Do it the American way. Why not? Sounds like fun. Yeah. There's that. Okay. We might have to take a detour here. We don't have GLM. C++, GLM. Opengl Mathematics on GitHub. It's a header only thing. Header only C++ mathematics library for graphics software based on the Opengl shading language. Code sample. Downloads. 0.998. Zip. Let's zip it. Do I get a thingy for that? Yay! We get a thingy for that. Baby XD lurk. Go for it. You're alright. We've got GLM. Fantastic. That was easy. Just zipped it down. In Linux, you probably just install it using whatever you use. Pacman, apt, silly things, whatever. Just get it from there. Get it from your package manager. Same thing. Get it from on a Mac. You can get it from home. What is it? Homebrew or just Brew or whatever. Whatever they use on Mac nowadays. I think I'll take the lot. It looks interesting. And it's header only. Dependencies. Add. New folder. Make sure it says new folder. Just click on the show all files if you haven't already. What are we going to call it? GLM. So I'm going to take everything. I don't care. It's got a readme manual copying. There's no license there. Well, that's their choice, not mine. And we're going to put it in amber skies. Dependencies, GLM. Hopefully that says paste. And there we go. It's over here now. Woohoo! Why is Windows so slow? In amber skies, under properties, C++, we will use solution. So $solution. That one. Yeah, that looks good. Solution directory. And if you're wondering about the fonts that I'm using, it's actually Comic Sans. I'm trying to revive it as a style of programming. Solution directory, amber skies. That's where we are. We will go into dependencies. Looks good. And GLM. Yes, Git submodules. I was doing that, but I found I was getting masses and masses of duplicate defines between ImGUI and GLFW, and I gave up with that and just started grabbing stuff whenever. So a couple of these are submodules, but hey ho. Each to their individual tastes, I think. Right. Oh. It nearly wanted to play. I'll put it in common. Yeah, Visual Studio complains a lot. So it's external. Hash include. And it's just going to be glm. There it is. And that's glm.hpp. Which is that one. And it's HPP because it's a header plus plus for C++. There is a .h version of this for C. You can use that, doesn't matter. CMake is very straightforward. Yes, it is. I use CMake in... what's that other programming IDE, which is a damn sight better than Visual Studio? IntelliJ, no, the IntelliJ IDEA stuff, the IDEA. Let me look it up. If you want a real IDE, but you have to pay for it. IntelliJ. JetBrains. This stuff is what you want. This uses CMake. Yeah, Sea Lion. Yeah, there you go. Free for students. You lucky, lucky person. I have to, well, I can't pay for it anymore because I'm not supported by Ember Skies. So that's why I'm not using it. Otherwise I would be. I wouldn't be using this trash. There's a couple of other header files I'm going to need sometime. No idea what they are at the moment. I can't remember. There's 3 early access builds. Really? You're joking me. Taking notes. Ah, running out of space. What was that? Sea Lion EAP. Okay. Early access. Okay. Put an extra C in there, we might even get better at this. Alright. Thank you. Thank you, thank you, thank you. I will look at that. I do have a spare machine that I can download it all onto and make sure it works. So I'll do that. Look, I've got GLM now, it's gone yellow. That was quick. I just want a Vec4 actually, because it's colour. Things I do for a Vec4, huh? I'll take it by reference and we'll call it colour. In the American way. It's how they get you addicted to the JetBrains IDs. Addicted? Addicted? You don't need to be addicted. Compared to this... oh my god, there's no such thing as addicted. It's just superior. It works. That's the first thing you have to realise. And the reason it doesn't give you the extra things here, these 13 warnings, is because these 13 warnings do not show up on a standard compiler. The MSVC uses a standard compiler, but has added a front end onto that to interrogate more warnings, like idiots that they are. There's no, look what the warnings are. Oh look, it's in core.h, standard library, format.h, standard library, casting the result to 8 bytes, cast the value to the wider type. I could block this. But what if I'm doing it? What if it's me? I don't want to be like them. I don't want to mess the I don't want to write it like the standard library was written. So that has to be done. Has to be implemented. Okay. So we need to clear the buffer. Actually, a couple of buffers, but anyway. So I'll have a virtual void to do that. We could just clear for that. It's a command. It doesn't take anything, I don't think, really. It does have to be implemented. We need a way of drawing. GL draw elements it is, I believe. Void. So let's just draw indexed. Yeah, I'll do. And what should we put in here? The vertex array might be helpful. Actually, the vertex array would be perfect. So we don't want it changing, we just want it to use it. Standard. We'll use a shared pointer. And it will be from the vertex, which we haven't got. Okay. This is part of the renderer, isn't it? API. Looking common. I'm thinking of doing that in common. This is the users include, not the game engines. That might be a good idea. So hash include what we've been doing today. Amber skies. Renderer. Why that one there got two thingies on it? I don't know. Sort that out in a second. Can't include self. This is a bad idea. Now this is definitely a bad... what am I doing? Z. Why have I got two slashes like that? What happened? That's a bad idea. We'll correct that. That's just totally awful. Hash include. I need the vertex thingy, don't I? Vertex Array API. Good. And I need a vertex array. That's fine. That should work, he says. Take it by reference. Vertex array. May as well call it that. And that has to be implemented. That's a must do. That's how I mark my to-dos, I guess. Weird idea. To-dos in C-Line are ace. They come up at the bottom. You can have them in the window and go through them, click on them, they go to them, and you can actually, like, do things. In other words, you don't forget about them. And we need a way to get the API, because that's what we've been doing. So we can have an inline static. Yeah, we'll do it that way. For the API. And it will just be get API. And that will return, you've guessed it, return the static, which we haven't got, API. Yeah, that looks good. I'll take that any time of the day. Lovely. So we need an S API now. Might be a damn good idea. Private. It's a private member. And it's just static API. And we're going to call it static API. Why not? I'll do it. Does that work? Well, the little thing at the bottom says no issues found. And we've now got a maths library. That's a bonus. So, maths, forget it. Don't care. How do you use vec4s? Who cares? I don't do maths when I'm doing 3D. Am I happy with that? Yeah. This looks a bit empty. Can we put anything in here? Do you think? We can make the API a singleton. Alright. So renderer API : API is going to be a singleton. So that's a renderer. Jeez, I hate doing these. API. I think. : no, this is not working. Yes, it is working. Cool. S API. And that equals something or other. Oh, let's set it. Yeah. We don't have anything except for OpenGL at the moment, so what I'm going to do is I'm going to set it here. And it can be a singleton. There we go, that'll work. That looks good. Wow, what a fantastic CPP file that is. So that's just a shortcut so we don't have to do too much typing and working things out. And we need a semicolon on it, don't we? Yeah, that'll do. No errors, no issues found. Good, I'm happy with that file. Right, done. I'll keep research open. I think we're nearly there. How nearly there are we? Need an include. That might be a good idea. That file's happy. Should have put the include here. Yeah. And it becomes renderer API, please. Thank you. This is working now. That's working now. that doesn't work. That doesn't work because we haven't implemented it. So we have to do those two. So let's do the renderer. Next. We're getting closer though. We are definitely getting closer. Everything works in here. That's a bonus. Right, renderer. Let's see if we can put it in here first. Because that is called renderer after all, and this is still API stuff. We'll see how this goes. I might change. Oh, my mind. God, that looks awful. CPP file. Okay, this is the language that we are trying to make, the API. I tend to have the API written out as a program first to make sure that I get it all right. But this is going to test it all. That one will do. That's today's date. No, it won't. That one will do. Okay. Renderer.h. Hash include. Ooh, that's a bad one. How's about common? Visual this Visual Studio thingy does have make and CMake available if people want to use it, by the way. Thought I'd mention that. I mean, I can't hit on them all the time and tell them they're rubbish because they are. We'll have the pre-compiled headers, please, Bob. And I'll want the renderer. Just go with R, please. That'll do. Do that. That looks okay. Right, that looks definitely okay. Let's concentrate now more on this. Get this file okay. Check. Check. Give an extra line. Yeah, that'll do. Right, we can start from there. Ugh. No idea what I'm going to need. Let's have a class called renderer. That's usually a good start, isn't it? Public. What haven't we got? Now the renderer isn't really too much to do with all of this, but we will have to keep that in the back of our minds, but that's not going to work. That's a direct render command. That's nothing to do with the game engine. That will come in here. That's bad. Is it though? Think about it. Okay, we've got most of this now sorted out. Done all the buffer stuff. So we're now down to render and camera, which we haven't even thought about yet. Okay, rendering. Again, a render command. We might be able, yeah, could happen. Begin scene, end scene, submit. I mean, that's what we're really doing for the renderer. These commands are direct. Begin scene, end scene, and submit with bits. Alright. Let's go with that. Make it static. I don't really want anything staying in here. It's only an API. Void. Let's start with begin scene. What do we want for beginning a scene? Or what should we know? We should know a camera. M camera. Amber : camera 3D. Camera 3D we'll call it then. Camera 3D and camera. We don't have that. Does that present a problem? Nah, carry on. We can make one later. Static void. The reason we take the camera in at begin scene is because the camera has a view matrix inside it. And that view matrix is a uniform and only needs to be called once per draw session. That uniform can be set at the beginning and just left as is. The camera doesn't move whilst you're drawing, put it that way. So we're taking the fixed point of where the camera is and we are sending that information into the scene for rendering at the beginning. That's the idea behind that. Probably a good idea, no idea if it'll work. End scene. We'll have one of those, because that sounds useful. Submit. That was the other one, wasn't it? And we wanted some bits and pieces. What do we want? There's my research. Can we put my research right up to the left, please? Thanks. Alright, so those are the things that we're going to need. So that's view projection matrix. Let's make that into a variable that we can use. Not a function. It's going to be nothing that we want to change, so it's constant. It's going to be a glm mat4. Mat 3, Mat 4. And we can take it in by reference. Yeah, that'll do. What's this one? This is basically a shader. And for that, we're going to use a standard shared pointer, as we've been doing quite a lot of all the way through, and we'll just need a shader, which we don't have. There we go, do now. That works. Vertex Array. Make that into a variable. And what's this one? They can make, these can all be const. We're not changing anything in here. I've already decided that. Const standard shared pointer, and it's going to be a vertex array. A vertex array, yeah, close enough. I don't think we've got that somehow. Hash include vertex array API. It should be in there. Yes, it is. Well done. And that satisfies the API. The only other thing that we haven't satisfied is that get API thingy, have we? So hash include render API, and we can put it in here. So it's going to be inline, static, a render API, and that's going to be get API, as we are going to implement it here probably. Yeah. And it's going to return render API. This is going to look stupid, but you have to do it because it's an implementation. That works, and it just looks stupid. But that's what APIs do. Looks stupid. And that'll do. To satisfy this, we just need a camera, 3D camera. Where can we put that? I'll put it in the same. I'll put it in the renderer. It's more to do with the window than the renderer. Camera 3D underscore API. I don't know. Yeah, that'll do. hash include common. Here we want class. I'm guessing it's just going to be camera 3D for now, because I can't think of anything else. Not complete. Hash include. There's a lot of includes on this one. There we go. That's got rid of that. Good. And we've got things to implement somehow. I doubt whether we will be implementing these as such. That's a void, doesn't matter, that's fine. That's a void, doesn't matter, that's fine. That's a void. Again, doesn't matter. That's fine. That'll do. I'm going to leave it like that because it needs to be filled in. Right. No errors. 23 errors. There's that, I suppose. We could do with a renderer here. That might help. Okay, let's go through these files. I think I've got enough information now to actually do a build, even if things don't do anything. I think we've got the start of an API. Okay, first, no issues found. I like that. That's fine. We need a renderer, so let's have one. Does renderer include renderer API? Yes. So that's that done. Thank you. We don't have an OpenGL Vertex Array. I'll just call it an OpenGL Vertex Array. So we want one of those. That will look very much like the camera, funnily enough. Except it will be class OpenGL Vertex Array. I don't know if it's going to survive in that kind of format, but there you go. Lovely. And we just need to include it. We can do that here. hash include angular brackets, it's not inside our place, platform, OpenGL, OpenGL Vertex Array. Thank you. Do you now exist? No constructor. Does not match the function type. I did something wrong. I'll just set it to default for now. Thank you. Are we okay? OpenGL Vertex Array new. Return value type does not match the function type. Return value is it trying to be funny with me? I think it is, you know. What type should it be? Yeah. I understand, I think. The OpenGL Vertex Array isn't just an OpenGL Vertex Array, is it? It needs our API. That's the other side of the boundary. Now I've got to be careful. I'm going to include that in here. What will I need to include in here? Yeah. I will need to include the vertex array. So I can't include that here. Is the answer. I have to include it in here. That's the first thing. This would need to include, oh god no, as soon as I do this it's all going to blow up, isn't it? Amber skies, render, Vertex Array API, because this derives from public, this is the implementation side of our Vertex Array, of that. That can work. What do you think? There you go. Object of abstract class type, blah blah blah, is not allowed. Has no overrider, has no overrider. See? I told you. We have to implement everything that's in Vertex Array. Okay, so we shall. Let's brush up on our OpenGL. I think we're going to have to do some implementation here. And for that we'll need a CPP file. OpenGL Vertex Array. Clunk. And hash include OpenGL Vertex. Why did it disappear on me? What is it doing? Thank you. Now I can't move. Right, okay, there. Alright, I'm confident with that now. Yeah. Now this is where I disagree with what I'm about to do. I'm about to put this OpenGL thingy into Amber. I don't agree. Shouldn't that just say OpenGL? Because that's the file, that's the folder that it's in. It's not in the Amber Skies folder. And it has to implement everything that's in Vertex Array. All of the zeros. And possibly a create. Didn't we do that one? Oh, do I need that? Do you think? We'll keep it. That's virtual as well. I may as well do all of them. So, what do we got here? We've got that. That's for certain. This is an implementation file. That's an override. That's an override. That's an override. That's an override. Looking good. That's an override. That's an override. Const. I thought, oh, stupid me, I've just taken the constness out, haven't I? They're all consts. Dum da dum dum dum. You can spot the ones that are const. This equals 0 you should take out. So add and set. We're okay. Good. Looks good. Looks brilliant. That looks fine. Doesn't that look ace? What do you think? This is going to be the implementation. What else are we going to need? We're going to need some kind of ID. It's a renderer, so we can call it a renderer ID. We'll need that vector of buffers and some kind of index buffer. That's all we're going to need, really, for storage. I mean, we haven't really been given anything else at this stage. Those are the only ones I've used so far. I mean, if we need other stuff, we can always make it. Oh, sugar. So yeah, this is the fun end of the API. This is where OpenGL actually occurs. So all of the OpenGL lines that it took to get the triangle on the screen, that's going to come from here. The vertex array controls quite a bit. Where's the layout? Aren't I supposed to have a layout in here? I hope not. Don't think the layout goes in here, does it? Nah. We will need to get a getter for the index and the vertex buffers. So there's that. Let's wobble my mind through the storage containers and then we'll do the getters. So for an ID it's just an unsigned int. I know that from experience. It's a GL int. GLU int, sorry. And we can call it member variable, renderer ID. I think we did the same in the shader. We need a vector of vertex buffers because there are multiple ones. So that's a standard vector. So let's start there and see what we need to add to it. It's going to be a standard whatever of standard shared pointers we're using, which has another one of those. This will be a vertex buffer. Which we should have. That comes from this include here. We need another close. And we can just call it a member variable. This is where it actually gets stored. Vertex Buffers. That's where the Vertex Buffers get stored. Not inside of the game engine. Because they are stored differently in different backends. Like Vulkan and stuff like that. It's all done differently. And we can just do a index buffer. Standard shared pointer, isn't it? Shared pointer for index buffer. All of this should now be in the system. It becomes a lot easier when you do it this way. And then we'll just call it an m_index buffer. It gets stored here. Why are we storing these? Because we might want to modify them later. Yeah. We might want to start digging into these buffers and doing things with them. And going from static draw to dynamic draw. And batch rendering, which we're not doing at the moment. Can't think of anything else. Something might occur to me later. Let's go down the bottom. Oh God, it's one of these, isn't it? It's these two. We haven't overridden them. Yeah, they have to be implemented. Okay. Let's pop them in then. See what we need to do. It's just the equal sign, please. And it's override. And equals an override. So this is where that command ends up. So this is the implementation of it. Let me just make sure I've got this right. Standard vector, shared pointer, vertex buffer, close, close, and get vertex buffers. And there's no return, is there, on this? We can, well, we'll just put them up there, haven't we? So instead of that, we can just do return. Underscore E. Oh well, just tab then. Like that. And here we can just put that return. And it's underscore index buffer. Because this is where it's stored, we can do that direct. Ah. Don't need anything else. What about these here? Why have they disappeared? Oh, I did copy them. I just ignored them. Oops. Double copy. That's right. Set, add, bind, unbind. Sounds good. A destructor in case we need it. Right. I think I can work with that. Don't count on it. Let's give it some implementation. I did just implement that, didn't I? No. Stunk. There we go. I can't be bothered opening the window for the last one. It did anyway. Right, so that's fully done. Has it put return types in? Oh no, there aren't any. Good. Shall we fill in the blanks? May as well whilst we're, because I know how to do these. Which is brill. Okay. This is where it gets a bit complicated, because we're now in OpenGL. If we look back here, it's not here. Where did we leave it? It's in the buffer. We left it in the buffer. All of the API for sizes and things. It's there. That's good. Let's open that one. Yeah, this one here. This stuff. That's okay. But that isn't. Shader data type, byte size. That's fine if you're using C++, but what's OpenGL? I'm taking that. I'm taking the whole lot. That's not OpenGL. OpenGL is different, and we can put it in here. Yeah, we can put it in here. Okay. To OpenGL. Yeah. I only want the data type. I'm not bothered about the byte size. To OpenGL base type, I suppose. So that's going to be GL float. So I'm doing the types. Is it in capitals? Yes, it is. These are all GL floats. We have to change them all, because OpenGL doesn't guarantee that it's not going to change. And this is external, so it could be changed at any time, which is why it's not in the main area or the core. These are floats. That it's just an enum. These are numbers. They expand to numbers. These are ints, obviously. I wonder if there is a bool. We're about to find out. We haven't done unsigned either. Damn. Never mind. See if we need it. Bool. Oh my god, there's bool, bool vec 2, bool vec 3, and bool vec 4. Jesus. They are hopeful. You could always put those in. Right, let's update this. To unknown shader data type? No. It's not. It's an unknown OpenGL base type. And we are not in Buffer API no longer. We're in Kansas. OpenGL Vertex Array. Well, we're just outside it at the moment, but hey, it's in this file. It'll do. It's going to be close enough for a biscuit if I need to find it again. As we have an assert, we should do it properly. Ooh, that makes this interesting. So, what does the constructor of an OpenGL vertex array do? Quite a bit. It has to call OpenGL. Oh, we haven't got it. It's next door. We haven't got OpenGL here, have we? We have. Okay. Create. It's going to be a vertex array, isn't it? That's what it says. And we will need one. And it's going to be and underscore renderer ID. There we go. I think that should do it. What did we put the renderer ID as? GL uint. Anything else I've messed up? No. Looks okay. Probably I've messed something up. So we just create one. Simple enough, isn't it? For the destructor, it's going to be GL delete, believe it or not, which we've been ignoring. Vertex arrays. Yes, you are supposed to clean up after yourself because it's on your graphics card, for God's sake. Do you want your graphics card to have a memory leak? There's the question. How will you know? Okay. Good so far? Are we happy? Awesome stuff. Alright, let's do a simple bind and unbind. Like I said, it's just implementation. There isn't much to implement with OpenGL. It's very, very simplistic. GL bind something. Vertex array. Yeah, that looks okay. And we can use the m_render ID. Have you spotted everything that's complicated so far? I told you OpenGL is just a set of switches. That's all we're doing, flicking the switches. We want to unbind, so we just bind. Bind vertex array. And I will unbind it using GL faults. Okay, now we've got some information to deal with. I keep doing that and I don't know how. It's something to do with the way my hand goes to the mouse. That's my problem. And not yours. Let's do some programming. Adding a vertex buffer to the vertex buffer. We haven't done the layout. I think we might leave these ones till later. If I try and find out the size of the vertex buffer, will I be able to? Because how would I have to do it? I would have to cast it to an int, possibly. Vertex buffer. Yeah, we've got one of those. It came in by reference. So an arrow. Do we have get layout? We do. Get layout. That's a function. Can we get the elements? Yes, we can. That's a function. Do we have the size? Do we want the byte size? That would be get byte size, wouldn't it? No, I think we'll just have size. That's a function. Oh, and a semicolon. Isn't that lovely? Hey, we can do it. We might be able to do this then, if we can get the size. So now we know the size of the vertex buffer. Woohoo! That's good. Because now we can do that. Yeah. And it's going to be size. So that's size not equal to 0. It cannot equal 0 or else it's useless to us, isn't it? We can't add a 0 because this is an adding a vertex buffer. So just borrow you a sec, mate. What we're going to put in here. Vertex buffer has no layout, because that's what that would mean. think I'd do it this way. Yeah, I'll do it that way. So at this point we have to bind the vertex array. We have bind here, don't we? That's that done. I don't know if we've got the next bit, so let's try it. Vertex Buffer. Can you bind yourself? Yes, you can. Good boy. We haven't implemented it yet, but you can try. Now we need the layout. Const. We're not going to change the layout. I don't know what the layout is off the top of my head, so we'll take it in by reference, and we'll just call it layout. And we can just use Vertex Buffer. Get layout for that. That will work. C++, isn't it? It's endlessly easy. Okay. Let's take a GLUint for the index. And we'll start that off as 0, as we always do. Now we have to do all that complicated stuff. For every single element in the layout. So, for, I don't know why I keep putting a space there, I shouldn't do really. For, const, auto, reference, element, back to this element type of thing. For each element in the layout, for each thing in the layout, you may as well say. And that's why we needed that assert, because otherwise we can't do this. There won't be any. We need to do something. This might be the last file I do today. This is not going to work straight off. I'm not going to be able to compile it, I don't think. So I'm not going to be able to release it to GitHub. Although I just did release a non-compilable version. We'll see. We will see. Depends how many files I'm missing. At this point, I'm just generating the files to satisfy the API. But I'm also trying to put the code in that's correct. We need to set... Well, no, we need to enable, don't we? We need to do those things that we did before, like enabling the... a trib array, that kind of thing. This bind won't do. Would it? I'm not going to risk it. We will do it ourselves. That's really a GL bind. The vertex array. We have to do that so it records. Otherwise it won't record. It's like a recorder. A vertex array is a recording device which records whatever we do to buffers. And now we teach that vertex array exactly what we want the buffers to do. A bit like recording a macro, I suppose, because that's how it acts. We'll use that. And that. Just in case. We'll do it properly. So each part of the layout, or each buffer, should I say, GL enable. Do it in the order that it makes sense. Vertex attrib array. That one, I think. Yeah, that'll do. Alright, what do we do next? Bada boom, bada boom, bada boom, boom, boom. We're going to have to do the attrib pointer, aren't we? GL vertex attrib pointer. Good God. That's the wrong one. Whoa! There it is. That one. I used the wrong one last time. Oh well. Doesn't matter. And that's going to be index. That's your first number. The index. That's what we called it. That's good news. Now we need the size. Get component count. Now we need the type. That one. The one that we just made up. That works. Now we need normalized. Oh, God. Don't look at what I'm going to type. Dot normalized. And we have to convert that with one of those silly things to either GL underscore true or GL underscore false, because we stored it as a Boolean, which probably would work, but I'm not going to chance it. Most people would use a Boolean. Next, we want the stride. That'll be in the layout. We don't have a layout. Sugar. We've got begin, end, and get elements. I don't think we can get it from get elements. Nope. Can't do it. What we need is element. Oh no, layout. We've got element. Layout dot get stride. I think we had a working out thingy, but I don't think we got anything onto the layout. That's awkward. And then we've got this silly offset thing. Good. That's right. It's a long. Had to make sure it's in base 64. Oh, well, sorry, 64-bit. Otherwise it gives an error. Well, warning. Damn it. We're going to have to leave that as an error, aren't we? There you go, it's an error. Do we need to do anything else? Well, would help if we incremented the index, wouldn't it? There's that. Yeah, I'll do. That's a shame. Lovely. So we're going to have to get a layout from somewhere. Yeah, blast. Right, so what are we on? I've forgotten what we're on now. Been doing all that. Add Vertex Buffer. Well, I suppose we should do that then. I mean, that's what it's all about. So that would be m underscore Vertex Buffers dot pushback and that's a Vertex Buffer. We're done. That's That's the whole point of that, but we actually have to record the layout at the same time, otherwise it's the only point where we can really do that safely. So if we want to set the index buffer, this only happens once, so we can do a GL bind here without any problems. Vertex Array. And we're going to do that using the renderer ID. And now we just need to set it, which is quite easy. It's m underscore index buffer equals index buffer. The one at the top that they sent in for us very kindly, and we're done. That's the only thing we've got left. Oh, wowsy wowzers. What did I do with it? Why doesn't the layout work? La 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 la. Vertex Array API. Where do we add the layer? It should be here. It's here. Comes under buffer layout. So we do have the layout. Why is it not tying in? Get layout. Well, we've got the layout, so why can't I get the stride? It's in the buffer layout. Because this is where we calculate it. And we set it. It's M stride and it's in private. M stride, yeah. So it should be just layout get stride. So something's not working. The object has type qualifiers that are not compatible with the member function. Amber buffer layout get stride. Object type is const amber buffer layout. What's wrong with that? Is it the const? Bet it is. You're right. The const should be at the end. Why isn't it? That's not right. I think it's that. I think it's there. Yeah. That should work. Const correctness. And it works. God damn you. God damn you, game. We did it. Wow. We now have an OpenGL Vertex Array. With all the OpenGL. And none of that OpenGL is in the game engine. Whoa. What were you complaining about? Oh, nothing. No issue found. Okay, that's worked. All corrections done. Shader, don't need to check. Renderer API. No issues found. CPP file. No issues found. There's nothing there. In the renderer, I bet we've just got the camera, haven't we? Oh no, I've fixed that by just putting a blank camera in. Context has already been done, needs to be checked. That's blank. Can't have a problem with that. Buffer API. No issues found. Okay. Where's the problem here? Which one do I include? Good question. we'll include the lot. I think that's got to go both ways. So we'll need a renderer.h. Hello? Why doesn't that work? Save. Ah! Kaplunk. I like getting rid of errors. Come on then, Poppy. Good girl. What we're missing? OpenGL Vertex Buffer. We'll have you then. Hash include. Where are you? You are in platform. OpenGL. And we want OpenGL Vertex Array. I think. Not. Ow. Sugar. That's a vertex buffer. We don't have one. I've just done Vertex Array. That's OpenGL Vertex Buffer. GL Vertex Buffer. Which won't be in an OpenGL Vertex Buffer, would it? We wouldn't have that because there's an index buffer to add to it as well. So it'd be OpenGL Buffer. New item. Header file. Kaplunk. Add. Take that line out, please. That's dangerous. What do we actually need? Return a new one with those. So we need you. We need that. OpenGL Vertex Buffer. Public. Just do that for a sec. Looks like I found a header file that I haven't got. Interesting. Okay. So we have to hook this into our buffer API. That's the first thing. So let's do that. Hash include amber skies renderer buffer API. We better make this a buffer properly. Public Vertex Buffer, I guess. My God, I'm getting good at this. We are going to need vertices as probably a GL float, I would have thought, at this point. I'll go with that and see what happens. Never mind. G, have we got it? L, I think we have. Float, oops. We do. We have GL float. I always get a bit nervous when I'm doing OpenGL and they're not there. GL uint. For that, don't have to put anything in at this point. There's no errors. I guess we just let it think about it. For feck's sake, I hate this. Hash include. It takes the P platform. OpenGL. OpenGL Buffer. What's wrong? Oh, crap. This is not allowed. It's basically saying that this is not allowed, because it isn't. It's quite correct. I specified that we have to implement. Fair enough. We need to implement Vertex Buffer. That's an implementation. I'll go with that for now and see how far that gets us. Override. Probably fill these in as well. Good. That's an override. And that's an override. How are we looking there? Are we looking any good for an Opengl buffer? What do you think? For implementation, we'll need the layout. Okay, so under implementation, we would store a GLUint, normal one that we use, renderer ID. Why be imaginative? And we'll need a buffer layout. Okay. Which we can have there. And that would be layout. All one word. Okay. That may be an override, but is there really any point in doing set layout like that? Can I put it in line? Layout. Equals layout. I'll do that one. Otherwise, we've now got a problem. Got green squigglies. Okay. CPP file. Opengl Buffer. Go me. And of course this starts with the usual includes. Why aren't these done automatically? PCH. I'm guessing that in this IDE there is a way of setting this up so it is automatic. Open GL buffer. It's just I don't know it. Oh, that's a clean one. We're still on the same day, aren't we? Yeah, good. And no, that is not a stupid question. I don't watch time. All right, it's that we're dealing with. Right, so we completed this one. Don't need the include. Pop you there. That'll be a good start point, I guess. Everything looks groovy. Hey, did I just say the word groovy? I did. Ban me. I think I need a cup of coffee. And stretch. What time are we on, actually? My God, why have we written so much? Still camera 3D to do. Otherwise, it's going okay. Will this system work? Yes. It's been fully tested previously. And this version has a lot less errors in it and a bit more preciseness. Although I've probably made different errors this time. Mind you, I have got everything consted up properly. That might help. Alright. So be it. Right. Go to notes. And working out a buffer. We've got the render ID, we've got the layout, we've got all the buffer bits, bind, unbind, we just got them all. We've got the set layout, that might help. This implements the get layout, that would help. We can probably do that one. Return, whatever. What we're returning here, M layout, yeah. Duh. It's the reverse, isn't it? I'll pop you there. Which leaves us with that. 4. And And the last two are very easy. Looks good. Okay, let's see what mess we've made. Okay. Could be interesting. Did we keep buffer H in here? Yeah, we have. Might do that way. Might not. Let's go with what we got. I'm going to start at the bottom though. Right, let's do the unbinding first. That should work. GL bind buffer, GL array buffer. False. Yes. Or 0 if you want. Your choice. How to bind the buffer? You just bind it. So we can just bind it like that. That should be alright. Destructor. You'll need the address. So that's GL delete buffers. So this is the OpenGL implementation of whatever we've been doing. And now we get to construct a buffer. Fun time. We have to add the index buffer to this, don't we? Indeed we do. Indeed we do. Alright, let's try it out. So, from memory of the other day, it's GL create buffer, buffers, plural. We want 1, and it's the reference to the rend ID. Pretty simple stuff. Then we want to bind it. So we can operate upon it. So that's a GL array buffer. And it's just straightforward ID. Okay, so we got it bind. Now we do the buffer data. Yep, that's good. Which is GL array buffer. Size. Vertices byte size. Vertices might help. I don't know why it's an error. And we're doing the GL static draw at the moment, aren't we? So there's nothing complicated there. Why doesn't it match up? It does now, okay. Oh no, it doesn't. Yes it did, no it doesn't. It doesn't bloody know. Gluint float. What should it be? Const void star data. That's the float star. It's right now. Cool. That's better. So it's a pointer. Okay, that one works. That's buffer data. That's it. What haven't we done? What doesn't it like? Okay, it wants me to put in equals 0 for some inexplicable reason. Render ID is uninitialized. Wrong. How long do you think it'll take it to work it out this time? Oh. So it's giving me a warning for that. You correct it and it does nothing about it. That's great programming. IntelliNonsense is the correct version of that word. Because I don't know now whether the warning's changed or not. Okay, whatever. Don't know why it wants me to go there. But hey ho. Who knows? Who knows the in-depth discoveries that this thing makes whilst I'm not looking. How far away are we? OpenGL index buffer. Yeah, we're going to need it. Good. It's not looking too bad. There's only 25 errors. That's fantastic. Well done me. Has that changed? Oh, it's gone. Great, we can continue. But that's all we need to do. We just need to operate the OpenGL commands. We don't need to do anything else. It's an implementation file. But saying that, we should really do the index buffer whilst we're here. Because it is part of the buffer API. So it's roughly going to be the same class. A repetition. And this is going to be the OpenGL index buffer. And again, we are going to inherit from the index buffer. And that should make everybody happy. Okay. So somewhere in here, we have an index buffer. It's probably right down the bottom there. There it is. I'll take that lot. We need to store count. That's about it, really. I do want a constructor, though. That'll do that one. That's an override. I got my overrides wrong somewhere, by the way. I normally do. I try to get them in the right place. Get count. Okay. We'll do the same things as usual then. GL uint m underscore renderer ID. You can always tell what's coming, can't you? GL uint count. I think that's all we need for an index buffer. Don't need much else. so it can't complain at me. Yeah, that'll do. We shall take in GLUint star. It's going to be an array, isn't it? Indices. And a GLUint count. May as well do this here. Return m_count. It's obvious what's going in there. So that's that one done. I think that's all I need from here. We'll do it. Go to there. Looks good. Looks better. Alright, so we're going to be doing similar things here, aren't we? Let's get some spacing going. It's not an array buffer though, it's an element array buffer. It's one of them. God, I even start to know this stuff off by heart. That's bad news. That really is bad news for me. So we can pop this up here. Again, I'm going bottom to top because it's easier to get this lot out of the way with. Okay, that's fine. GL delete buffers again. Yeah, that'll do it. And it's just going to be one buffer, and it's going to be the address of, isn't it? m_rend. ID done. Right, that's all the easy stuff out of the way with. Let's deal with this little baby. There we go. Not a difficult one, it's exactly the same as what we've already done, basically, isn't it? Close enough, really. Create buffer, bind buffer, buffer data. And that's what we did last time. Slightly different though, obviously. So, GL create buffer, yeah. Bind it as an element array. That's a good idea. Keep it as an element array. There we go. it wants the count. Let me make sure of this. Target size, yeah. So it's count times the size of og of a gluint comma. Now we're at indices, not vertices. And everything should be good. That's it. That's all I can think of. No issues found in here. Mind you, do we believe it? That's the problem I have with this integrated development environment. Do I believe it? It says no issues found in here. We now have Opengl buffers. Or don't we have? Oh dear. Oh dear. We don't have something. Okay. Amber Skies renderer.h. Syntax error. Bracket. Inline static renderer API get API open close bracket. Okay. That usually means something's out of sync. If it's saying something strange like that, because that's how you would normally put it, isn't it? Hold on a minute, that bracket works, that bracket works, that bracket works. That's why I do my brackets in such a way. Alrighty, let's fix all this rubbish. Let's try something happening with the renderer. It shouldn't be. I'm interested in that bracket, but I don't think that's a problem. Vertex Array. Undeclared identifier. No, it's not. I'm in the renderer API. Yeah. There's Vertex Array API. Yeah. I've got a feeling that somebody's pulling my chain. So one of these doesn't belong to the other. So this list is useless to me. Output. Thank you. What's the first error? buffer API.cpp error 8832. Let's go there instead. Buffer API CPP. Yeah, it's here. And it wants 8832. Oh, it's here. We've got two errors. Return value type does not match the function type. Size T size. Well, that's a straight call through to Opengl index buffer for a new one using the indices and the count. Amber Opengl index buffer, Opengl index buffer, OpenGluint star and gluint, and I've got float star. Why have I got float star for indices? What's this doing here? Since when was that a thing? Where are we? We're in Buffer API, aren't we? Since when was that a float? Just check my notes. God, I've got a lot of notes. Yikes. There's... I would say that's an unsigned int, wouldn't you? Thank you. Unsigned int. Good. I wonder how far back that went. That's Buffer API, so that's the only place. Then it goes forwards. And we corrected it with gluints on the other side. Good. Amber Skies source, Amber Skies renderer, Buffer API CPP 89.5. Oh right, it's going into there now. Oh, it's got a cannot convert there. Cannot convert from Opengl index buffer to Amber Vertex Buffer star. Cannot convert? It's on the return value here. And I can't use a gluint. Does that mean I can't use glueints elsewhere? Bet it bloody well does. So it's these conversions I think it's having problems with. It doesn't know what they are. No, I'm putting that in. That's fine. I'm putting that in. That should be fine. Can't use them though on here. Okay. So it knows what we're talking about. I might have done it badly at the other end as well. Okay. We'll do it that way. Doesn't alter much. Indices, unsigned int. Yeah. Okay. I wonder if you can do that operation there. We'll find out as we go through the errors. That's the only thing I can really change there. That I can think of. Okay. Output. It's still not happy about it, is it? From that to that. Index buffer to a vertex buffer. Why is it doing an index buffer? It should be doing an index buffer to an index buffer. I've done something stupid. OpenGL vertex buffer. OpenGL index buffer. Why is it doing an index buffer? I'm asking for a vertex buffer. This is on 8832. Right, well, we've done that. So, hey, we're past this one. We're on this one. How can it like one and not the other? Je ne comprends pas. I've got a feeling it's the other way around. It's trying to go from an index buffer to a vertex buffer. What do you think? Should that be an index buffer? Maybe. has something to do with it. Yeah, I would think so. Got a feeling that might be an index buffer on the output. Maybe that could help. Alright. We'll try that. Oh my god, we got put past Buffer API. Okay. Sorry. I love doing these. Mind you, I've typed out so much garbage. We're on to renderer.h. Cool, we got rid of buffer altogether. Buffer's gone. We're on to renderer. This could be a bad include, actually. Renderer.h. Vertex Array undeclared identifier on 4526. Huh? I think it means here. Well, it's not directly accessed, it's accessed through the Vertex Array API. Is there a better way of doing that? No, there isn't. That is a direct access to Vertex Array. It's here. So that's a bit of a mystery. Let's have a look at that output again. Let's read it through. So it's a bit weird. Okay, Amber Skies source. Amber Skies renderer.h. That's what I've got in front of me. What? Vertex Array undeclared identifier, that's the first thing, which is untrue. The next thing it says about it is that the standard shared pointer Vertex Array is not a valid template type. Well, it wouldn't be if it's an undeclared identifier. Well, I can go to its declaration, so there's something stopping it somewhere else. (4526). There. It's very unhappy about that. So that might be something wrong in the renderer API. Submit. There is no submit. Renderer has submit. The renderer API doesn't have submit. Render API. What have I got on information on that? How did I get GLM Vec4 there? I put it in common, right. Set color, clear color, draw index. I know what we haven't got. We haven't got command. I've actually got a file missing. And that's in the vertex area. It's this. This is a command. It's got nothing to do with this. It's this. It's a command. These just don't exist. There you go. That's what's wrong. That's the best it can do. It's trying to find it in I'm GUI. The poor little sausage. So what am I doing to correct that? There's something not quite right here. We haven't integrated the render commands into this. That's right, we haven't done the GL clear color, and we haven't done the depth buffer, we haven't done anything like that. And yet I've got it happily sitting here. Something smells fishy. Yeah, it does. We've got a file missing. Well, 4 files missing. There's no command structure. Dum 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 dum. That's what all this is about, by the looks of it. It's not the line that's wrong, it's what comes before it that's wrong. When you trace it back. It's just got no implementation at all. What should we call it? Render command API? I think so. Camera's still not done. Make a note. I've got check shader. We've got camera 3D to do. That's been done. We've got GLM. Yeah, we haven't got definitions for those. I mean, we've got them here. There's nothing in here, is there? No. And there's nothing in there. There's nothing in there. I'll submit. Yeah, we'll fix that. I think. There's nothing in there. But we have these here. Does this actually have something? Let's find out. Go to definition. It goes to... oh, go to definition. And it doesn't go anywhere. And that goes to rubbish. Yeah. That's why it's not working. Thought we might have to have some commands in here somewhere. We'll call it render commands. Render command API. Yep, because this is only our side of it, not the OpenGL side of it. You've got to keep that in mind at all times. So it's best to do something like that. Go on, I'll make a CPP file, why not? I'm really enjoying this, sorry. I'm having a really good day today. I think this is the final file, except for the camera. Alright. I'll just borrow you a second. Second to second, still the same date. Pop you in. Okay. Nearly. Get out of it. Looks okay there. Hash include. Good old PCH. Hash include. Render command. There we go. Give it a quick flick on here. Do that. There we go. That might help. Good. 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 Good, 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 good. Right. So here we need to include the render API. It needs to be pasted in here. Hash include. Because that's what we're fixing. So this is the render API, not the renderer, the renderer API. And that's important. Okay, we've got common. That's GLM and everything, isn't it? That's good. What we're going to have, a class called a render command. And it's going to do all the bits that we're not doing. This will complete the API, hopefully. Now, how should we do this? A renderer API, can we have you or not? Hold on a minute. Did we not? Yes, we did. Right, so we've got that. We can have a renderer API. Okay. Otherwise we don't know what the hell we're doing about which one of these we're in when we're doing our commands. I'm going to try this and see if it works. Will it work? Good question. Let's use static so it doesn't go anywhere. So it'd be render API, and I just want to make an instance of you as an S static render API. Render API. So that works. Yeah. That makes sense. I don't want it to go anywhere. We want an inline, because this, again, is API. It shouldn't be doing anything, this file. So everything's going to be static or inline, or both, if we can get it to that far. Inline, static, void. What have we missed out? Things like set clear color, maybe? You know. A little bit. Not a lot. Don't want to be messing around with anything, and we do need GLM for the color. Const GLM, it was a vec4, wasn't it? If I remember right. Vec4 by reference, we've just called it color. Looks good. Looks good. Right, so now inline, stuff it, we'll put it here then. Static render thingy, what have we called it? Could you please do me something and set the clear color to whatever we were given, color. Okay, that gets us over to there. So this is one end of it. Alright. What else can we do here? We can clear. So inline. This file does nothing but an API. I would think. I hope not anyway. Clear. Why did I do it that way? I mean, I can just do that, can't I? Because all I'm doing is passing it along the line. It's an API. This is a pass-through. And I'll leave that one. And of course we've got the last one that was in there, which was the draw index, wasn't it? Inline. Static void. Draw indexed. No messing around, standard something or other, shared pointer. This is a shared pointer it probably couldn't find. And it's just a vertex array. Like that. Yep, that'll do it. And all we're going to do is the sRender thingy again. Right, this should get it in motion. And that one is draw, indexed, open. And it wants a standard shared point, vertex array, and a vertex array. Should do it. Yep. Okay. Looks better. Looks okay, actually. So if I put that in the command.h, what can we put in command cpp? We can put the rendering bit in, can't we? It's another one of these. I remember. It's one of those weird ones. Because it's an API. So we're doing a render API star render command colon. It's not working. Yes, it is. Cool. Fantastic, it's working. That would be a new open GL. Oh god, what are we going to use? A hash include map be in order for here. Platform. It's going to be OpenGL, and it's going to be the OpenGL renderer API. Which we don't have. It's the one we haven't done yet. That's bad. A new one of them, please. No, just a new one of them. Doesn't matter about the brackets. We don't have one. So we'll need one of those. Include. This is how it all filters through. These are the bits that we're missing now. This is ace. This system drags you by the nose all the way down the path, doesn't it? Well, I'm fine with the API. Yeah, what the hell, why not OpenGL renderer API? Okay. These aren't hard files to make. And that's the whole point to these. We'll also need the implementation, because this will possibly be the implementation file. Which means I named it wrong, really. Did I name it wrong? Should we name it something else? This is coming from render command API. It's a judgment call. Okay. OpenGL renderer. Take the API off the end. I don't think that's right, because we don't have the API in here. This is an implementation file. That's better. Alright. Doobie doobie dum dum. That one looks okay, nearly. How are we doing, chat? Are you alright? I've been absolutely snowballed with making files. Hiya, it's Alice Winfield. Good to see you, matey. I'm up to my neck in creating the worst ever OpenGL renderer. And I've just literally got to the file OpenGL renderer. Crimes. Get rid of that lot. Because I like doing stupid things like this. I think it's funny. That'll do. Shall we make ourselves an OpenGL renderer? I think we shall. We will need to obviously include the API, which is in amber skies. Actually, as of today, a lot better, but the last few days, a bit tricky. I'll be taking tomorrow off, by the way, because I still feel a bit iffy. But otherwise, okay. Which is always good to know. That's how we're doing at the moment. I'll take the renderer API. That's you. So what are you up to? That, what is it? Lost in Eve podcast is ace. Absolutely ace. Really enjoyed that. Or am enjoying it, should I say. Haven't listened to it all yet. Good stuff. Absolutely. So, just making an OpenGL renderer. It's not something you do every day of your life, you know. Just sit down and decide, oh, let's make a renderer. Public. Yeah, it is. It's my style of thing, isn't it? Chilled. Sure it's that Texan that I know. Really, I'm sure that I know the guy. But hey ho. Okay. Why don't I like this? Something not quite right. I have little jinglings in the back of my mind. This is the implementation for this virtual void. Are we going public with this? Yes, I think we better had. There we go, public. Don't think it stores anything in here, I just think it's commands. Literally. So this is set clear color. This is where people lose how the hell the system works, because this doesn't make sense. All of a sudden we've got set clear color coming in the renderer. How does that happen? Well, it's quite easy. That's where we need it. It's renderer API we're overdoing. Yeah, that's correct. I should have copied and pasted them, but never mind. We'll try and remember them. It's GLM, Vec4. I'm getting used to this bit. It was a reference, and it's a colour. That sounds about right. And we better override it. That is an override. Is that right? Yes! That's working. You see? Virtual. Did I return something? No, I didn't. Good. Thought I had put a return in there for a second. Void. Good God. I'm going mental. Clear. We'll give this an override. As we're overriding the renderer API file, that one. Just doing the overrides now for the bits that were missing, the bits that it was saying, hey, we can't do this. I'm going to try to build the program. And we had the last bit, the draw index, didn't we? Virtual void draw index. What we got in there? We had the const. Oh God, I hate this line. Const std shared. Didn't pick it up. Hate you. Shared. I'll get that bit right first, shall I? No, I'll pick it up. Shared pointer. And this is where it comes in. This is where the vertex array, why it couldn't find it. It couldn't find this here in a definition file. Array, vertex array. Doesn't matter what you call it actually. You can call it anything at this stage, just like what I did by pushing numbers. And again, that's an override. And we should have 3 functions. Yes, we have. OMG. Hello, Poppy. Are you alright, love? I'm being attacked by the cat again. I do need to finish this now. Yeah, we are out of time. We're in overtime. And I do need to finish this rapidly. Okay. Well, that's not hard to do. Have we got GLM? Yes, we have. Good. Let's just click on these and do clickety-clicks. Oh. So it's the definitions it needs in here. First one's dead easy. This is just clear color. So it's GL clear color. Hopefully we've got that coming up. We have clear. Capital is it? Yep, color. That looks good. I will just drop down into there and go back up. Because now we've got color. Now, GLM is very nice to us. Watch what it does. Color dot red. Yeah, look at that. Color dot G green. RG. Guess what's coming up? B blue. And we have an alpha, don't we? Yeah. So I'll put a dot A in. And GLM takes care of that for us. That's done. Clear. Bit different. We're going to do a bit extra than we normally do. I am going to clear 2 things. So it's the GL... Sorry about speeding up. Color. Buffer. Bit. Yep. And we need to OR that. Because it's a bit shifter thingy. It's a bit mask. Oh, it's bitty. Okay, no, bits and bytes. Color depth buffer bit. I just need to chuck this together now before I go get some food. Because I'm late. Depth buffer bit, and then we'll be very close, and I'll tidy it up tonight. and stick it up on GitHub. So really that's all that needs to do for a clear. Do we enable? No. The draw call should be quite simple for OpenGL. It's GL draw elements. And just throw it together now. What do we have? GL triangles. We want triangles, obviously. So I'll have them. What else does it need? It needs the vertex array, which we've got. If I popped it on the screen so people could see it, like that, we do actually have it. And it's a pointer. And we can get the index buffer. I hope. Yes, we can. And from the index buffer, we can probably get the count. Fantastic. Done. It's full of GL unsigned integers. Like that. And the last value, who cares? It can work it out itself. Did we bind? Don't need to. Good. Next. Done. That's it. That's the whole file. That was hard. That's what we're missing. Is there anything else I'm missing now? We've got vertexes, we've got renderers, we've got contexts, we've got buffers, layers, God knows what they're. Vertex array done, shader done, renderer done, render API done, render command just done, camera not done. Context we've got, buffer we've got. Whoa. I think we've got everything. Oops. Hello, Poppy. Now, come on. Be good. I know I'm late. So there you go. That's the full design. It should have a happier time with it. Maybe not. Poppy, could you please stop? That is... It doesn't help if you're sitting on the keyboard, love. Go on. Now I don't know if these are real or not. Damn it. Okay. So, renderer.h, we're back to there. Good. That's a good place to be. I liked renderer.h. Did I include everything there? That should have done. Absolutely, yeah. So it's still throwing a little bit of a paddy about renderer.h, which is good. I don't mind that. Right, so that vertex array is still undeclared. This is in Vertex Array API. There. So it's now pointing at the right line. It's not a valid template type. It doesn't have a constructor. That could alter things. Which shouldn't matter. Let's go through these now. Which line is it actually complaining about? Can't shared point vertex array submit. I haven't seen submit. We haven't completed submit. Where does submit go to? It's not been completed. Oops. What have we got here? I don't care about the other two. So we need a backing store for the camera. Can't do anything with that. But this is shader. We should have all of this stuff already. Bind. So we wrote the shader some other time. Shader. Upload uniform map 4 we haven't got. Shouldn't matter. Just put it in. There you go. Done. Easy way of programming. Vertex. We have to get the vertex array to bind in here, which might help everybody involved. And then we have the render. Do we have the render commands? Yeah, command. Probably not in this file though. No, not in this file, we don't. God damn it. Sticky. Hash include. I don't know which order it's supposed to go in. And that's just render command. There we go. Pop you in there. Good. Now we've got commands. Yeah. Cool me. Draw indexed. That's your vertex array, which comes from there. Shader, yeah. View projection matrix. We're supposed to be storing that. Maybe. And I think this is the last attempt of today, and then I'm going to start looking through the code and picking out the errors and doing it properly. Ooh, big hesitation. Wow, that's not bad. For something that I've just splattered out in an afternoon. Still doesn't like that one. Still doesn't like that one. See declaration of vertex array. What's wrong with this vertex array? It's the simplest thing going. It's virtual void. It's getting stuck on the vertex array for some reason. There's nothing there. The only thing it can get stuck on is that create. It's saying that that's not integrated either. That comes from renderer. Got it. And the buffers have the other stuff. Interesting. Just wondering why that's in a different static. Is that right? Yeah. The only thing I can think of is that we've got a loop. It might sound stupid, but there's probably a loop of includes going on, because there are so many different includes in varying places that it could get tricky. And that's your last try. So we were at whatever. It says 67. We are now at 1. There you go. We had a loop of includes going, so it's including itself and going on forever. Output. It's in renderer. Render command API.cpp20. That's the last thing I did. Typical, isn't it? So render command API.cpp. Yeah, I just chucked stuff in there, didn't I? Damn. My bad. Oh. Oh. But I did put in boss. Did I put it in the right place? Platform. OpenGL. OpenGL renderer API. I took the API off. Did I call it API? Did I hellers like? Everything lights up. Solution build. Cannot open include file GLM. Now I know it's just taking the P. So the code's good. GLM isn't. Who's trying to open it? Sandbox. You're right. Yeah, I'll do that. I'm not bothered where it goes. Let's borrow you. Let's borrow you. Take I'm GUI off the end and type in GLM. So I have just done the impossible. Done. We're done. Doesn't mean the code's right, as you can tell by some link errors here. But hey ho, that's Sandbox's problem. What's Sandbox doing with GLAD? That's what we're taking out of Sandbox. Ugh. That's in the rendering object. Because of inlining. Oh. Never mind. So we broke our sandbox. Oh no. Because we put something in amber skies. Not. There's GLAD. We haven't put any of the renderer in here. That might have something to do with it. Shouldn't. But the code compiles. I'll work on Sandbox. I'm going to have to go. Otherwise, things are going to become a mess around here very quickly. So, what's all this crap? Where? From a search? I want that lot. Okay. We need that. We need GTC, yeah. GTX we need. SIMD we need. Everything else in here we need. That's good. That's GLM done. Okay, a couple of submodules, blah 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 blah. Those are all the things that we've added. Okay. Basic code, untested for the rendering API. Sorry about that. Not time to test it right now. I'll do that later tonight. I will probably fix it up and get something running on it. And we can't do submodules. Okay. Of course. Done. That's a renderer in an afternoon. so I can sort that out. I'll track those errors down and get the sandbox up and running after I've had something to eat. You lot take care. Don't do anything I wouldn't, like write a renderer in an afternoon. And, well, got camera 3D, and I've got to check that shader. What else have we got now? Sea Lion, that's going to be worth looking at. Wow, all go. I'm taking tomorrow off. So I'll get this done for you. What is it? Control Z? No, Alt Z? Yeah. Take care, peeps. And above all, have fun.